Hello, my name is Sai Janani Ramachandran and my colleague Anand Bhaskaran. We together have made this movie presentation on the title Privacy, Security, Trust in IoT Systems with the focus primarily on security in IoT systems. So this is how our talk is going to be organized. First, we're going to talk about start with an IoT introduction, and then we're going to talk a little bit about privacy, security, and trust, and then the rest of the talk will be dedicated to talk more about the security challenges in IoT, the possible measures, the standardizations, and we're going to talk a little bit about the protocols existing, and then we're going to conclude. So here we go.
Imagine everything was linked. In a near future, the Internet of People will evolve and become an internet where everyday objects can be recognized and controlled via RFID tags, sensors, and smartphones. This will allow the creation of smart environments in which objects will interact and cooperate with each other. An Internet of Things. Our quality of life will undergo a vast transformation and will be improved. By 2020, 50 billion devices will be equipped with unique identifiers so that they can be of great benefit in the fields of energy, safety and security, industry, manufacturing and retail, healthcare, independence of elderly people and people with reduced mobility, environment and transport, smart cities, entertainment, and many more. Since the system will be controlled by a free market like today's internet, the risk for data misuse or data security cannot be excluded.
Like the video said, with IoT evolution, we are going to a technological era where we're going to benefit from a lot from the things that are interconnected. The things are going to talk to each other and talk to the internet to provide a better quality of living for the elderly people and the people with disabilities and overall to everybody. With all the good packages in IoT, there comes the bad ones. Since most of the times the IoT, the smart things, are unattended, it gives a lot of opportunities for the hackers to hack into the things. For example, I attend to my smart TV only when I want to watch a movie or some drama or something in it, but rest of the time it's going to be unattended. So this is the reason why hacking in IoT is very crucial, and it's more expected. So there has been a lot of research and developments in the area to make IoT a more secure and more reliable one. With being said, we're gonna talk about privacy, security, and trust. I was exactly like this guy in this picture. At the first time when I was hearing the terms privacy, security, and trust, to me it all meant the same. But there is a fine line between privacy and security and trust. So I decided to put this slide to talk a little bit on that. So what privacy is? Privacy is the prevention of information exposure of individual. What it means is every individual must be equipped with the right to decide to whom his data or his location or whatsoever will be visible and from whom it's hidden from. So this makes IoT a lot different from the other devices. For example, there is a smart public camera which takes the feed of the transport in the public from the public, and there is also a camera in your home to grab a feed from inside your home. These two are very different things. The camera from inside your home should not only be able to be reliable, it should be able to prevent itself from malicious attack of the government, or the malicious attack or the government intrusions or some random data scrape. This becomes a very crucial thing, and privacy of every individual is a very important thing to be dealt with when IoT is concerned. And next comes the term trust. Trust is primarily the embodiment of two different terms. One is the transparency on the one hand, and then comes the consistency. What transparency means is a device, a IoT smart thing, and its functions should be visible to the user. What the device does, how it can be controlled, what it interacts with, and everything is visible to the user. And what the consistency means here is the behavior of the devices according to the expectation of the user. For example, if you want to control my Philips Hue with a smartphone, and if I keep it as a red color, it should be red. That's what this means. The hue is consistent with my expectations. But these two terms must go hand in hand, not lack of either of the terms. Like there should be trust, consistency, and there should also be transparency to make this IoT a trustworthy one. On top of this, on top of this comes a next term, the security. Security is primarily top of this because once security is broken, there is privacy is endangered, and then your trust is endangered. So security is the assembling factor of the IoT that protects all the devices from unauthorized access or connections or intrusions and everything. So we decided to talk more about security in the further talks. In order to put things into more perspective, we have this diagram here. We have taken this from one of the reference papers, and it typically shows what are the interacting nodes in IoT and what is the interaction between them. The circles mentioned here, the person, the technological system, the process, are together bounded along with the intelligent object to create an IoT system. The interconnection between say a person and the technological system is referred to as privacy. This connection is referred to as tension in the paper. So there are different tensions between different nodes, and there are different tensions like privacy, safety, responsibility, trust, reliability, and then and etc. So the trust, according to this paper, the security is the governing factor of all these tensions. So when security is broken, there are a lot of chances that everything in the IoT system collapses. So security is the primary focus of IoT in the research and development these days. So what we're gonna talk in the next slides is essentially this. We're gonna try to answer these questions. Why is security necessary, and what are the challenges in IoT security, and what are the measures taken so far? Are they good enough? We are primarily focusing on answering these questions in the next few slides. So to answer the first question, we thought it would be nice to have a couple of videos. When we were browsing to find content for the presentation, we came across these two videos.
So he's in complete control.
He's in complete control, that's right.
Minutes.
This is the normal configuration that if you bought it off the web and you brought it home and started playing it, this is how it would work. So are you ready, Pat?
Yeah. So what's Pat going to do?
So Pat is playing the role of the malicious hacker. He's going to connect to the quadcopter and tell the quadcopter to stop listening to Dylan. So Dylan won't be able to do anything anymore with the quadcopter. Pat will have complete control. So you want to tell us when you've gone ahead and taken over?
I'll do it right now.
Okay.
Playing the role of the malicious hacker, he's going to connect to the quadcopter and tell the quadcopter to stop.
I've lost control.
So Pat's in complete control.
So now are you in control,
Dylan's
Pat?
lost control.
Yeah, so Dylan no longer has control. Pat, can you make it go up in the air?
Right now. Okay.
Oh my goodness.
Can you make it like wiggle back and forth so it says hi? Yeah, so it's like jiggling.
I've lost control.
And then can you make it land?
Oh,
Whoa!
you kill the drone.
Dylan no longer has control.
So you did that.
Can you go up in the air? Oh my goodness. Can you make it like wiggle back and forth so it says hi? Yeah, so it's like jiggling. And then can you make it land? Whoa! You kill the drone. So you did that.
That was a funny video, yeah, but it explains how security is crucial in IoT systems. You're seeing a drone being hacked, but the next video is something more serious.
This is a regular new car. The masking tape is only there because we agreed to obscure its make and model.
We'll give them the illusion they control the car for now.
Kaufman has been working on this for 5 years with multiple research teams.
You want to hit the fluids?
Oh my gosh.
There we go.
There we go.
What's that? What's that? What's that?
That's the windshield wiper fluid.
No, wait. So this is something that a hacker hit.
That's right, a hacker. Like obviously you didn't turn on the windshield wipers.
Using a laptop, the hacker dialed the car's emergency communication system and transmitted a series of tones that flooded it with data. As the car's computer tried sorting it out, the hacker inserted an attack that reprogrammed the software, gaining total remote control.
Oh my God.
The horn.
They're doing that?
They're doing the horn.
They could control the gas, the acceleration. They could control the braking.
That's right.
And they could do this from anywhere in the world.
So just stop at the cones here.
she thinks she's going to be able to stop right at those cones. Let's make sure that she can't, and she's going to drive right through them.
All
We'll
right.
have complete control of that brake.
All right, here we go.
Oh, no, 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 no.
Brakes
I
didn't
cannot,
work,
oh
right?
my God. I can't operate the brakes at all. Oh my word. That is frightening. That is frightening.
This video shows how serious security in IoT is. Just to empathize, put yourself in the car that is internet connected and you're applying a brake and it doesn't work. How freaking it is. So with security in IoT, we are talking about lives of people. So this is why a lots and lots of research has been put into this area to make security more stronger before we step into this IoT era. There are these organizations, IETF, IEEE, 6LoWPAN and Core, working so hard to standardize a platform where the different security measures coming up from different people could have a standardization, and then they could work their applications upon it. And this is a picture that shows a malicious attacker, and the different types of attacks possible, like he can either take control of my devices, or he could steal my private information, or he could disrupt the normal services. So this is why we need security in IoT. So what makes it more difficult? For example, if you want to secure my home, it's simple. I have all these different options shown in the figure. But when it comes to IoT security, it's difficult because of the following reasons. I'm going to mention 3 constraints that make it very difficult for security to be implemented in IoT. I would not say difficult, but then a little challenging. The first constraint is the constraints already in the things. So IoT has these things, the smart object, which are not as resourceful as our laptops or computers is. It can operate in the low bandwidth communication. They are very small nodes with very small processing powers. They have very low memory. They have the memory constraint and also the power constraint. So this is the first main constraint that comes into picture when whatever is concerned about IoT. So the next constraint is the enormous amount of devices. So Ericsson and Cisco predicted that by the end of 2020 we'd be having 50 billion connected devices. So with this huge number of devices, whatever the security measures we are putting in should also be able to scale up to the devices number of like ever expanding devices. So it's not just for hundreds of thousands of devices it should be able to expand or cope up with, but then billions of devices. So this is a second constraint. Yeah, like this picture says, we have billion devices and we have billion points of vulnerabilities. And then the third constraint is the heterogeneity of IoT systems. So IoT is not just a single system, it is an amalgamation of different technologies. You have hardware, you have software, you have rules, you have services. Even in hardware you have different kinds of vendors, for example Atmel or TI. But in software again, you not only have different vendors, but you already have different kinds of software. So you have different platforms, you have different frameworks, you have different cloud service providers, and you have different network providers. So all these heterogeneity make the new attempts or the standardization more needed, and it makes a little complex the task. It makes the tasks a little complex. So this being said, we're going to talk what are the challenges these constraints are posing. So with the first one is the identification and authorization of the devices. So if you have billion devices, you need to identify them individually, and then to who to gain access to what is the next challenge. And then you want to have a proper protocol stack to every device, and then comes the issues of privacy, trust, and then it should be redundant, it should be fault tolerant. So these are the challenges those constraints pose in terms of security in IoT. First, we're going to talk about identification and authorization. In the past, when RFID was there, we used these kind of identifications, that is the electronic product code and U code. But then it's no more valid, because we're going to talk about billions of devices, and then you run out of names. Of course, if you try to connect these devices, like attempts are being taken to connect them via IPv6 and IPv4, and then taking the same question comes into picture. Like you cannot have billions of different addresses for every devices. So what's the solution? Solution is hierarchical naming. So you have your smart home, you have an edge router which has control over all the things. So this edge router takes care of the authentication of the devices inside your home, and this authentication by the device is used, the central device might be any other device, not essentially an edge router, but then the authentication from it is used by the other cloud services to know if it's an authenticated device contacting. And when it comes to identification in the local, when it operations between inside the home, you have separate local addresses, and when you have the interrupt operation between the cloud services, then you what is suggest is to take a temporary name from a global namespace and use it for the particular connection. So this is not been standardized yet, but this is one of the most talked solution for identification and authorization problems. And then here comes the access control, whom to control what and who has the read-write opportunities or something. I forgot to mention earlier, when there are different architectures of IoT. One is the centralized one, where the things are connected to a central entity, and then this entity contacts to the cloud service. And then comes the distributed IoT, where every device is equipped with the capability to process, provide and data directly to the cloud by themselves. So when we talk about the centralized IoT, this access control becomes a little easier, because you need to just feed what kind of access you want into the central entity, but in the distributor it becomes a little longer with a lot of data providers. So the two things are access control list, and then role-based role-based access control. Here, role-based access control, you just define a list of rules, and then you add users to it and multiple users to it. This is how it happens, and RBAC is much preferred compared to ACL for IoT. And then here comes the protocol and network security, and the primary focus of developing this is to support the existing standards. So here we have CoAP and DTLS for constrained devices. CoAP is primarily developed protocol stack for IoT devices. It is developed by having in mind the constrainment of these devices. And DTLS for constrained devices, DTLS is being used by Cisco AnyConnect. It's a very secure means of communication and secure protocol stack we have known so far, but then it's being renewed to be able to apply to the IoT devices. But then when it comes to protocol stack, you think, why not HTTP? It's been used for a longer while, but the thing is, it's not applicable to IoT. The reason is here, because in traditional HTTP you have one long packet with security message at the end, but in IoT it's not possible to send such a long message, but you send the messages in fragments with a lot of security messages. Here comes another vulnerability, because instead of sending one security message, you send a lot of security message along with every fragment, which makes the job of hacker a little easier. He don't have to do so much of brute force to know what the security message is. In order to compare like a fight with this, we have AES and SSL standards, but then it's no longer applicable because of the constraint we have in the IoT things. So we have the standard modified AES, which has the data link as CMAC protocol, and then for the network layer we have HIP or diet HIP. These are the standards that were developed and not standardized, but then more likely to be standardized. So the next comes challenge is the privacy. For the distributed systems, the privacy is more easy, because the hacker doesn't hack into the central system and take out all of the information, but he has to hack into every system to get the information he needs. The distributed architecture is privacy by design. It's more private, and means that they have security mechanisms inherent to themselves. But when it comes to central kind of architecture, centralized IoT, the research is yet to be done on how to improve the privacy. And trust and governance. Then you have a lot of sensors around in your room. Say for example you have a radiation sensor. If for example you must know which sensor's value you should trust. Each one might sometimes give a different value, and you should be able to know which is the correct value of the sensor. So you must be able to answer who can give me a robust and timely service or a timely value of the data, and how can the reputation and trust be calculated. In order to obtain a solution for this, a firm called UTrust IT came up with solutions. They use digitally signed user-defined groups and ratings for this purpose, so that the trust and governance of the devices around you is maintained. And next is the fault tolerant. Like any other device, you need to the IoT need to assure it's redundant, it has holistic and then detailed data, depends on what kind of architecture it is. So this not only does these challenges that and the protocols does not make up IoT in entire, but then there are also other things that needs to be considered. For example, we have incremental deployment and end-to-end security. These are the purposes, these are the requirements that are needed to make IoT as a wholesome. So we mentioned a few other purposes and the protocols that are more likely to be implemented for this purpose. For incremental deployment, we have internet key exchange. For end-to-end security, which for incremental deployment means to be able to be scalable, and then for end-to-end security means the complete security for your connection to the internet and then the data from the cloud, etc. like that. And for that you have Mobike and IKE v2. And for identity and key establishment mobility support, you have TLS and DTLS, which we have talked about a little while ago. And then we have privacy aware identification and group membership management. For that we have the protocol called HIP for that. And then for group creation we have PANA. In order to make you more clear which goes where, we have made this slide which shows this. So yeah, like for the network interface, there comes the extensible authentication protocol, that's called the EAP. And then for the internet connection, you have the direct HIP or HIP. And between the internet and transport layer comes the internet key exchange protocol. And then for application you have co-op, and then transportation you have TLS. So with this we come to an end of a talk about security in IoT. To conclude, we conclude with a quote from Atmel. Atmel says, Internet of Things has the potential to change the world just as the internet did, or maybe even in a larger scale. That's true, yeah. But this can be achieved only if the platforms, the infrastructures, the identities, the applications, and the networks we are using can be formed or can be put into a secure cloud. Once this security in IoT has been achieved, we have a smart city, the interconnected smart city, that is not only secure but is completely reliable and completely trustworthy. So we took all our data for this movie and presentation from the reference papers, and also from some data from the internet. For more details you can look into these papers. And thank you for watching. And since it's a YouTube video, I would like to say this. If you like this video, please click on the like button, and please subscribe this video. Anyways, we are not going to put more videos into this, but please like the video. Okay, have a nice day. Bye bye.